Let's now discuss what an argument is. The argument, theta, of a complex number is the angle made by the vector of the complex number and the positive real axis. So we have our positive real axis here. The argument, or the angle theta, is equal to the degrees from the positive real axis to our modulus, or the line that represents our modulus here. Now the argument is going to be the shortest angle that gets you from the positive real axis to the vector of the modulus. So in quadrants 1 and 2, you'll be moving counterclockwise. That'll be the shortest way to get to the vector. In quadrants 3 and 4, you'll be moving clockwise, since this will be the shortest angle to get to our vector. We'll discuss that more as we move along. Now, since we were dealing with right triangles, as we saw when we were looking at the modulus, the trigonometry functions sine, cosine, and tangent can be used to find the argument theta. So quick review, remember SOHCAHTOA helps us understand the relationship between the angle we are looking at and the three sides of the triangle. So SO means the sine of theta is equal to the opposite side over the hypotenuse. So we have our angle theta, the side opposite over the hypotenuse of the triangle. Ca represents the cosine of the angle, which in this case is theta. So ca is cosine adjacent hypotenuse. So the cosine of theta is equal to the adjacent side divided by the hypotenuse. Adjacent by hypotenuse. And TOA lets us know the tangent of the angle is equal to the opposite side over the adjacent side. Opposite over adjacent. Now, if the complex number is known, then use the arctan or inverse tangent to find the value of theta. So, if we have some complex number, a plus bi, this side is going to have a length of a, equivalent to our real number along our real axis. B is the length of this second side here, or the opposite side of our theta. Since b is along the imaginary number, it's the same value as this imaginary number. So if we're looking to figure out, do we use sine, cosine, or tangent? Well, if we look at SOHCAHTOA in relation to our sides, a, b, and r, tangent of theta is the one that we can use just by having the complex number. Sine of theta is equal to b over r, opposite b over hypotenuse r. But if we know the complex number, we would then have to calculate the modulus to figure out theta here. So we want to skip that step, calculating the modulus. Cosine of theta is equal to the adjacent side over the hypotenuse, or modulus. Again, we don't want to have to calculate the modulus when finding the argument. So that is why we use tangent. Since tan of theta is equal to b over a, just by having the complex number, we'll then have a and b every time. Thus, we'll be able to use tan theta for b over a. So the inverse tangent of theta will then give us what the angle is. So the tangent of theta provides the ratio of b over a, but the inverse tangent provides the actual angle in degrees. Now the arctangent, or the inverse tangent, provides the angle that has a tangent of b over a in the first quadrant. And I say the first quadrant because as we move to the other quadrants, these rules will slightly change. Okay, but in quadrant 1, the theta angle is shortest from the real axis to the vector of our modulus. So the arctan of b over a will always give us theta in degrees in quadrant 1. And remember, arctan is equivalent to the inverse tangent. This is what the button on your calculator probably looks like. So throughout this video, we'll be using inverse tangent as opposed to arctan, but just know they are equivalent. Now degrees versus radian, we'll be providing each answer in both degrees and radian throughout the rest of this chapter. Quick review. 1 revolution or circle is equivalent to 360 degrees or 2 radians. So if you start here, the positive real axis, that's considered 0 degrees. You move through quadrant 1, which is a total of 90 degrees. You move through quadrant 2, which is another total of 90. So now we're at 180 degrees. You move through quadrant 3, which is another 90 degrees, getting us to 270 degrees. And you move through quadrant 4, the final 90 degrees, to give us 1 circle, or 360 degrees total. 2 radian means you start at 0. You go halfway around, so that's 1 radian. You go the remaining half around, so you get to 2 radian. So that means halfway between 0 and 1 radian, we have half a radian. And halfway between a radian and 2 radian, we have 1.5, or 3 pi over 2 here. 1 radian is equal to pi, which is equal to 180 degrees. And 2 radians is equal to 2 pi, which is equivalent to 360 degrees. And this information is helpful because if we want to convert an angle from degree to radian measure, then we multiply the angle by pi over 180 degrees. Why is that? We see pi, which is equivalent to 1 radian, is equal to 180 degrees. So if we multiply an angle by pi over 180 degrees, since pi is equivalent to 180 degrees, we are actually multiplying that angle by 1. Any number divided by itself is equal to 1. So we are not changing the actual value of the angle. We are changing how we represent that value. We're changing it from degrees to radian. So let's take a look at this. If you found an argument that was 80 degrees and you wanted to change it to radian form, 80 degrees times pi over 180 degrees is equal to 80 divided by 180, which is 0.44 radian. 120 degrees in radian form would be 120 degrees divided by 180 degrees, which would be 0.66 radian. And 220 degrees divided by 180 degrees would be 1.22 radian. So we'll use pi over 180 degrees to convert our arguments from degree measure to radian form so that you can answer the questions that your instructor asks you in either or both forms. Let's say you're asked to find the argument of 3 plus 4i. So this would be in quadrant 1. When you are calculating the argument, you should always sketch out the right triangle that you are working with so that you can confirm what quadrant you are working with, which will make it easier to avoid making any small mistakes when calculating theta. So we'll first start by finding the argument in quadrant 1 for 3 plus 4i. So step 1, go to 3 on the real axis. Step 2, draw a dotted line up to 4 on the imaginary axis. And then step 3, plot the point. So this point represents 3 plus 4i. And then from the point to the origin, you want to draw a line. By doing so, we've now created a right triangle in quadrant 1. That lets us know that this angle here, closest to the origin, is our theta, or the argument that we are looking for. The angle from the positive real to the vector of our modulus is equal to theta. So now that we have our right triangle, we know that the adjacent side to theta is 3, our real number. And the side opposite of theta is 4, the imaginary number. And with our right triangle, we can now use the inverse tangent of theta, which should be opposite over adjacent, or 4 over 3, to find out what theta is. So step 5, find the inverse tangent of 4 over 3 with a calculator in degrees mode. You plug that in, and you get theta is equal to 53 degrees. And if you want this answer in radian form, multiply the answer by pi over 180 degrees. 53 degrees divided by 180 degrees is equal to 0.29 radian. So the answer would be 53 degrees or 0.29 radian. Let's have you complete a few practice questions. Question number 1. Find the argument of 2 plus 6i. Question number 2. Find the argument of 4 plus 5i. And question number 3. Find the argument of 3 plus 7i. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1, we're asked to find the argument of 2 plus 6i. Step 1, go to 2 on the real axis. Step 2, draw a dotted line up to 6 on the imaginary axis. And then step 3, plot the point. Step 4, draw a line from the point to the origin, creating our right triangle, letting us know that this angle closest to the origin is theta, our argument. So we create our right triangle that has an adjacent side equal to the real number, which is 2, and an opposite side equal to the imaginary number, which is 6. So now the 5th step, find the inverse tangent of the opposite over adjacent, which would be 6 over 2, with the calculator in degrees mode. So we get theta is equal to the inverse tangent of 6 over 2, which gives us theta is equal to 72 degrees. And to get this answer into radian form, we want to multiply it by pi over 180 degrees, giving us 72 degrees divided by 180 degrees, which is 0.4 radian. So the answer to question number 1 is 72 degrees and 0.4 radian. Question number 2, you're asked to find the argument of 4 plus 5i. Step 1, go to 4 on the real axis. Step 2, draw a dotted line up to 5 on the imaginary axis. Step 3, plot the point. Step 4, draw a line from the point to the origin, letting us know that this angle here is our theta, or our argument, which means our right triangle has a side adjacent to theta that is equivalent to 4, the real number, and a side opposite of theta, which is 5, the imaginary number. So that lets us know in order to find theta, you find the inverse tangent of opposite over adjacent, which is 5 over 4. And you do so with a calculator in degrees mode. So we plug in theta is equal to the inverse tangent of 5 over 4. And we get theta is equal to 51 degrees, which is located in quadrant 1. And to get this answer in radian form, multiply 51 degrees by pi over 180 degrees. 51 degrees divided by 180 degrees is equal to 0.29 radian. So the answer to question number 2 is 51 degrees or 0.29 radian. Question number 3, you're asked to find the argument of 3 plus 7i. Step 1, go to 3 on the real axis. Step 2, draw a dotted line up to 7 on the imaginary axis. And step 3, plot the point. Step 4, draw a line from the point to the origin, letting us know that this angle here is our argument, or theta. And since we now have our right triangle, we see that the side adjacent to theta is 3, and the side opposite of theta is 7. So finding the inverse tangent of 7 over 3 with the calculator in degrees mode will give us our argument, or theta. So the inverse tangent of 7 over 3 shows us that theta is equal to 67 degrees. And in radian form, you multiply 67 degrees by pi over 180 degrees. 67 degrees divided by 180 degrees is 0.37 radian. So the answer to question number 3 is 67 degrees or 0.37 radian.